All right, we are back and continuing with our review of visualization functions for version 12.1. Okay, where have we got to before? We were looking at complex stream plot. We were realizing that the situation is somewhat different. So like complex region plot, there's only one color that is involved there. Is that correct?
Yeah.
I mean, you can have multiple regions and they'll get different colors.
Sure.
Yeah, okay, but fine, but it's a flat color.
Correct.
Right. So, by the way, this thing about the geo base maps and coming up with some new default color schemes like the black and whitish color scheme to go behind a to go behind the geodensity plot seems somewhat important to me. I think geodensity plot is not going to look good until we have that. Makes sense.
I mean, I think.
And if you're saying that's the default, right? Yeah, I think themes are easy.
Fine. Well, I think so. I mean, those are geo themes, though. So, I mean, we've got to take all the geo colors and bring them down to something much more gray.
Well, I'm not even sure that you necessarily want as much color or as many things colored.
No, I know. Yeah. I agree with that. But I'm saying, minimum case, we could just take all of the hue, all of the, just desaturate all those colors somehow. That doesn't quite make sense. I mean, take all those colors towards gray. I mean, we could just try it as a piece of image processing, just see what that does.
Mm-hmm.
I think it's going to look a lot better.
On what time scale do you think we will get themes for geographics?
I don't know. Jeremy, do you know what this, or Jose, do you know what the status of that is?
Don't think we have Jose at the moment.
Okay.
So I should be working on them maybe starting next week.
But
well, no, I mean, but that's
that are rasterized from tiles are going to be hard because they take up a lot of space. So it'd be some graphics post processing maybe.
Yeah. I mean, I'm thinking that needs to be a giant. I mean, there's the mechanism. So first of all, designing themes is one thing, but what we found is that we often need to design the mechanism.
Yeah, I know, but
in the
we
case of
just
geographics,
Roger, we just spent 2 years updating the geo server. It's now finally done.
If it's just a server, I mean, the data needs to be updated.
No. The data has been updated. That's the whole point. And the whole point is that what we're going towards is vector-based graphics.
That's what I was going to say. It needs to be, I know we're going towards that, but I have no insight into the rate of progress in that project.
Well, it's been slower than one might like. There have been a lot of issues.
Yeah, and I think that's the key discussion point for our geo meeting tomorrow.
Okay. Fine, but I'm just saying there may be a cheap solution that involves pure image processing of the tiles. Okay, I mean, like for example, I don't know what's the image processing operation that will literally make that grayer. What's it called? There's got to be a way to do that.
It's blend, isn't it?
I guess so. I mean, it's a
blend it
little
to white or something.
Well, that's not very good, but there's got to be some operation that will do that, right?
Yeah, there's an image adjust setting. I forget what it is that has saturation in it.
Okay, but I mean that would be the most minimal thing to try, to see whether it looks decent, because it's just not going to look very good. If you have orange, density values just going on top of green parks and so on.
Right. I mean, the other approach that you get, with say radar maps is they go, as the plot part goes sort of full saturation.
What do you mean?
I mean, so like if you go to like say Wonderground or something and look at a radar map for the weather.
Yeah, I know. And the background goes to more or less outline.
No.
All right. I don't know. Anyway, you guys can look at this. Okay, let's keep going here.
Yep.
Okay, multi-panel plots.
There's nothing to look at with those. It's just the list of things that are going to get multi-column layouts as extensions to chart layout, and I can't remember if Smooth Histogram uses chart layout or plot layout. I think plot layout.
Okay. All right. This is just extending region style to more functions. Is that correct?
I mean, region style is a new thing.
Yeah.
Oh.
Okay, so this came up, so for instance, when you do contour plot 3D, then you see there, if you don't give a styling of the boundary of that region, you have no depth queuing. You just can't perceive it.
Okay, so let's just understand this. So we've got,
and then our point was that similar issues comes up for vector plots as well when you have that over a region. What
happened there?
So, man, this is a region. This is the volumetric region. Is that correct?
Yeah.
Right.
But you're plotting contours of that function over that region, over that volumetric region.
I'm confused. This region style represents that throughout that volumetric region, it is a pink. It is thoroughly pink all the way through.
In the case of 3D, it's not throughout. It's just the boundary.
Exactly.
Okay, so if I were to clip this sphere, I would see inside the pink.
Yeah.
Correct.
Okay. So this is showing the region, that is the ball.
Mm-hmm. Mm-hmm.
The outer, the skin. This is like the skin style option of anatomy plots.
Sure.
Sort of, yes.
And in general, if you read the reference page there, it says there's two styles. There's going to be an interior style and a boundary style. And in the case of 3D, there's only a boundary style. We have our graphic system has no way of styling the interior of anything volumetric.
Okay, but I mean, there's a clipping style in general. If we were to clip the edge of that region, right? But by the way, don't forget. You should put it in the see also the anatomy skin style really is extremely analogous to this.
Okay, I'll make a note for that.
That looked just like a bug, Stephen.
This one here.
Yeah.
Where it blew up.
Just some bug. I mean, let's just look at this just for a second to see what this actually does. Right. I mean, it's the same type of thing. It's contextualizing the data that you're seeing. Okay. So here, yeah, it's the same deal. So wait a minute. So in the case of 2D, this region style, you don't have that yet. But in the case of 2D,
if you go back to the other notebook, there's an example of it in vector plot. There.
Where regions? I don't see regions.
Right. I mean, so in that case, it's coming from a region function instead of being plotted over the region.
What do you mean? Where is region style here?
Right under your cursor. Those ovals.
I don't see a region style though.
Right. I mean, the region style is automatic, and so if you have something that isn't the full region, it kicks in.
So if I say region style,
well, it's not going to work because prototype build failed and whatever. But that would give you a yellow disk.
Fine. So that is the styling of the region, if there is a region.
Correct.
And there are two styles, interior and boundary.
And how are those characterized inside the region style thing?
So you see it's light blue inside and it's dark blue, the boundary for the ellipse there.
Yeah, but how do you say that in the region style?
It's a pair of colors. Similar to exclusion style.
Does edge form also work?
I'm not sure. I mean, it probably should. The question, and I think it will. The thing to be careful of is depending on how that region gets, constructed from, say, an implicit region or something. There may be interior structure that an edge style would pick up.
Okay, well, how did we do this previously? How did we determine that color there previously? Is that just plot style?
It's not quite plot style. It's close to
but
plot.
How was it determined previously? If I say region plot here, and I want to make that yellow or something, right?
Oh, so sorry. Yes, that's plot style.
Okay, so explain to me why that's plot style, but why something else is region style.
Because it's the primary thing for the plot.
Okay, so presumably region style should still work here and do that with region.
But it's not doing any region here. I mean, if you plotted a region plot over a region, yeah.
Okay, but let's do that. I mean, so if we say this, and we say region function arrow, why doesn't that work? Why doesn't that work?
Because it's already a region-y thing.
Okay. Well, I mean, arguably this should work.
It might.
Didn't. What determines the color of the boundary of the yellow region now?
Boundary style.
So why exactly is it that you want region style to just be one? So otherwise it would be, boundary region style and interior region style will be two different options. Is that desirable? Is that not desirable?
It seems heavy for what it is.
I'm just worried about the function, something called region style, which sounds extremely generic, being something kind of obscure like this. Given that it isn't even all regions, it's regions that are kind of secondary regions. It's regions that were determined, regions that arose because they were carved out by region function. Roger, do you have any comments on this?
Yeah, but kind of what you're proposing is making it even more major by making it two options. Do you see what I'm saying?
No, I agree. I understand, but I'm concerned that if somebody sees region style, they're going to think it's a much more important thing than this secondary use. And if we are going to have region style, it better be supported in region plot, even though it may be synonymous to plot style. What other things have regions in them? I mean, every kind of plot. I'm very confused here. I'm sorry. I'm very, very confused, because if I do a random, plot 3D, something like this, and then I say region function arrow this, right? I'm going to get that. Beautiful. Okay. So now my question is, if I said region style arrow pink here, what would it do?
It would pink the region style thing out because it's not a supported option.
Roger, I shouldn't have chosen pink. I'm sorry.
Okay, so theoretically, if it's supported or when it's supported to region style, right? I mean, there's sort of two possibilities here, right? One is that it shows a planar disk. No, actually, for the region function, there's only one case. It has to show a cylinder.
I see. The skin is the cookie cutter, so to speak. Is the locus of the cookie cutter doing the cookie cutting, so to speak.
Right.
Yeah. I think that weird. No, but it's a question of us thinking through. I mean, there's another project of.
Look, I like this skin idea. Okay, I think it's useful to show skin, so to speak, in these things. I think it would even be useful here.
Yeah, if you did filling to bottom here, you would get it. Okay.
Okay, well, let's look at that. I don't think I would get it. I think I would get
You
only
would get
partial
half of
skin.
it.
Yeah.
I don't think we have a way to do full skin. So, that's why I'm advocating that the more common thing here will be boundary region or region boundary style, because that would make it clear what's going on here. If we did region boundary style.
So, but you're clear, right? The region boundary in 2D is just a curve.
I understand that.
Okay.
But
Often,
the problem is that the region style here we can't live up to, because the full region we're not dealing with. We're only dealing with the skin.
that's right.
So, which is why I'm suggesting that if we could do it here, if we could say region boundary style in this case. Now, the only case that we are missing is this case here, where the interior of the region is rendered, right? Which we can't get. Okay, and we don't care about that for region plot because that's the main event, and so it's the plot style, right?
Mm-hmm.
So this is a secondary rendering, and I personally advocate calling it region interior style, and that it simply isn't supported in 3D yet, although it may one day be so.
How do we feel about the name region filling style?
Not terrible. I think I like that. I like that, actually. I mean, what about filling? Wait a minute. What does filling
style we have? And so, region.
No, I understand that, but what would filling style do in this case? What does filling style do in a vector plot?
Nothing.
Okay, because there's nothing to fill. Okay, so my question is, if there is a thing which has a meaningful, okay, either the region is the main event, or the region, if the region is the main event, then it is there, what does filling style do for region plot?
I don't think anything. I mean, filling style only.
Filling style was designed for functions, for curves and surfaces, to fill between two things, and that's how the whole thing is described to do.
Yeah. Okay. Fair enough. Okay. I think this should be region filling style. I like that name. And what we could do. Look, here's what we could do. Region filling style could take edge forms if it wanted to, so you could switch the two of them together. But the more common thing and the documented thing for the 3D case would be region boundary style.
Mm-hmm.
Unless we want to go anatomical and call it region skin style.
I don't.
Fine, then let's not do that. I'm too squeamish myself. Okay. All right, I think this will work. Roger, are you okay with this?
Yeah. No, it's the same thing. It's split on two options. It seems fine.
Okay.
And because then, when often you hear me object to when we give too many missions to the same symbol, because then you can't.
No, I know.
Documentation is not object oriented, so to speak.
Yeah, right. I understand. Okay, let's have a quick look through any other things here, and then we'll go on to the next topic. Did you get these notes, by the way? Do I have to send this to you?
No, good. I'll just screen cap it.
Okay.
Okay.
Okay, so default colors are still to come here, so we'll need to look at those again.
Mm-hmm.
All right, and there's nothing more in these, because these are a little bit funky. I mean, complex region plot is showing the flat region that satisfies a Boolean predicate, correct?
Right.
Correct.
So those are common shapes. There include sectors, disks, annulus.
Okay, so if I say complex region plot of like abs of z cubed is greater than 1. Mm-hmm. Z goes from minus 4i. I wish I didn't have to give these specifications like this. They really are a nuisance.
They are a pain to type. I agree.
I wonder whether we could do something different. So here's an idea. If we say z, 4, maybe it's the unit. It's the bounding square around the unit, around the in other words, z comma 1 would be the unit circle.
Unit circle or units, or the minus
No.
1 to 1?
Minus 1 to 1. The thing bounding the unit circle, so to speak.
Right.
I think that will be useful. And I don't see any problem with that.
I don't think there is. I mean, and we can implement that easily enough, I think.
Fine, let's do it. Because I get really annoyed doing these. I have no idea what any of these look like. Wow, that's not very exciting, is it? So if I do this, what? Why doesn't that work?
Same reason as region plot doesn't work for curves and points.
I see. So that will be complex contour plot. So if I say, if I do this and I say complex contour plot, that's not going to work because it's a less than 1. I don't know why the contour plot doesn't work for that. I guess it's a Boolean. So that is such ugly colors, but I understand the thing. So now if I say equals 1, good, I get the curve. Okay, all happy. So now in the case of complex vector plot, I don't even know what that's doing. Okay, so that's going to give vectors.
Now it really needs to be, yeah, I mean, so that's a real valued thing, so they all point.
So they all point to the real direction. Okay, very cool. Okay, now let's talk about arrowheads for a minute. Okay, they're pretty heavyweight here. What are you doing with arrowheads as if I did a plot, if I did an image size arrow tiny, no, I'm not all arrowheads, good. Image size full, those arrowheads are really too heavy, in my opinion.
So are they too heavy or are they too heavy in relation to the shaft?
I think primarily to the shaft, but I don't know. Jeremy, do you have an opinion about that?
So if you said, vector style goes to thick on that.
Sorry. So it's saying vector style goes to thick. By the way, I really like that that change we're just describing about the z comma 4 being the unit. Not the unit. The
rectangle.
Yeah. I wonder whether we should do that with No, we can't do that with other things. That's not a plot 3D thing because that's a feature of the fact that it's a vector thingy. Oh yes, Sandra is pointing out that on our live stream is pointing out that plot range arrow 4 gives -4 to 4. Yeah, it's absolutely consistent. A plot range arrow 1 in graphics and graphics 3D, plot range arrow 1, it's consistent with what plot range does. Okay, so I'm sorry, what were you saying? So that looks less ugly. It's not great, but it's less ugly. I mean, is Jeremy here?
I'm here, yeah. I don't mind this at all. Especially you can actually see the color now. So if you go much smaller on both, the color's kind of pointless.
Fair enough. So the issue here was without this, what would be, if I say thin there, for example, yeah, that looks terrible. Well, I mean, it does or it doesn't look terrible. I mean, you could decide that the arrowheads are the main event.
If you do this, you might as well just get rid of the shafts altogether.
Yeah,
I agree, but I don't think that's obviously bad. But that's what you get in your vector. What are you calling it? Vector markers.
Right.
So is there something that is, all head, no body type thing for the arrows?
There is, but it's a very triangle thing. I think there's room for one that's a bit more, has a little bit more style to it.
Yeah. By the way, Sandra is pointing out the problem is that the line thickness doesn't scale, but the arrowheads do. He's right. Or is he right? I mean, the line thickness scales in a situation like this. What happens to that line thickness?
That thickness, I mean, thick is an absolute thickness.
I see. Which is probably wrong. So, I mean, if the arrowhead is scaling, so should the thickness be scaling.
Right. Although, I mean, that's what thick is. I mean, if you do input form of thick, or
it's an absolute thickness, yeah.
Yeah.
Okay, anyway, look, work needs to be done on this. We got to get these, I mean, these arrows need to be more consistent and need to scale properly. Fair?
We'll see what we can do.
Okay. I mean, that sounds like a Tim issue. I don't know. But, okay. Did we go through everything here?
I think so.
Supporting multiple regions.
Oh, right.
Go ahead.
Sorry, yeah. I forgot we hadn't looked at region plot 3D.
Is that, I mean, is there anything unobvious there, so to speak?
Not really.
No.
So, I mean, by multiple regions, you just mean if I say x squared plus y cubed plus z to the fourth less than 1 and, you know, something else here.
Yep. Then you'll get 2 volumes in different colors and...
Now here, it'd be lovely if I didn't have to go.
You're missing a comma in the x spec after the -4.
I am. I'm also actually no. Okay, cool. Well, now we've got those same famous colors again. They look good together. But Jeremy, I'm sorry, were you here for that discussion about the color flipping?
Yeah, I was.
I don't know what to do about it. I mean, these colors look beautiful together, but I agree that it's crazy, that this color flipping thing.
It wasn't clear to me if people wanted them to match but be distinguishable or whether they should be completely different.
I think matching but distinguishable would be nice.
Mm-hmm.
And it might give us an opportunity to redo the color of our core plots. I think this blue is a bit dull.
But
I think
which blue?
Don't want to start with blue, but not that blue. I mean, we have a more vibrant palette that we could use.
Well, I don't know if we want to start with blue. I'd be happy to start with a color other than blue, like a reddish color or something. I mean, I think they're looking a bit drab these days.
Mm-hmm.
I mean, I'm not sure you want to start with red, but
not bright red.
I was going to say, I remember,
I think we adapt because these colors was sort of a big step up from the legacy default styles. And now we've adapted and gotten used to that, and we want to step it up again. And I think it's nice. It's natural. Yeah. I'm just saying that we've adapted.
I don't think that supports call out yet. Actually, I'm sure it doesn't.
What would it do? Does it support any of those things labeled?
No.
Does it support legended?
Legended, probably not yet.
Those would be nice to have. I mean, that's.
I mean, legended, absolutely, we should make work.
Does call out work at all in 3D?
Call out work for some
for some things, but like parametric plots, 3D. I think has
why if it worked for parametric plot, why the hell doesn't it work for region plot? I mean, it doesn't seem like it's
because
it's working on parametric surfaces right now.
Right, but the other thing is
arbitrary regions.
Yeah, but the other thing is that for these functions, the wrapper support was not very complete. So new parsers, new ways of handling it needs to be written for each one.
I see. So if I were to do parametric plot 3D. I don't know what I can do.
And just look at the docs.
Well, I mean, you're saying to get an image. Okay, so let's say this one here. I don't know what this really looks like, but and then if I say, oh, I see, I need multiple, whatever.
I mean, you only need one. I mean, you can do a call out on.
Okay, but if I were to say call out /@bat. Doesn't that work?
Why is that? I thought we supported parametric plot 3D. Maybe it's only the curve case. Or maybe I'm just completely confused, which is possible.
So you're saying parametric plot. Let's just see. I mean, it would be nice to support more of these. All right, so you say, okay, so that looks like it's successfully legended. So in this case, we could say something like, oh, it might need an evaluate. Is that possible?
That is possible. Or it's possible that, oh, okay.
Let's see what happens if I don't have the evaluate.
You probably do need to evaluate.
Well, so maybe these other ones actually did work better. Well, so in fact, we don't actually know that these didn't work. I wish we had a better heuristic for determining whether you need evaluate. I mean, at least advising the user when the thing's going to come up with a blank plot. Oh, that worked beautifully. You know what? Can we talk about that for a second?
Sure.
If it's going to come out with a blank plot, couldn't it heuristically determine that it needs evaluate?
Possibly. We might even be able to determine it earlier.
Why don't you look at it? Because it's silly. In these cases where, in a case where it's like mapping call out or something, we kind of know we need it.
Mm-hmm.
Let's have a little effort to try and do that. So, I mean, we don't even know whether this one didn't work. Let's see whether this one worked.
I am sure that one didn't work.
Well, at least didn't give an error there.
Right.
Okay. There was a couple of questions on the live stream. One is about support for a round in 3D. Does that work?
Not yet. We might get a little bit of that in 12.1, but it wasn't ready by today. So.
But how is it going to work? It's going to make ellipsoids?
So we're looking at adding support for a round to list plot 3D and list point plot 3D. And you'll probably have, sort of the stem approach, the lines and orthogonal directions.
I see. So it'll look like one of those jacks. So it'll look like one of
curves.
Fine.
Not bounding curves.
Right, but so it'll look like some kind of coordinate axis jack type thingy dingy.
Yep.
Got 3. Does that look decent?
It's not great looking.
I've never seen 3D error bars like that.
I'm pretty sure I have, but it's still a little bit early. I want to experiment with using like little tubes for the lines instead, just to give it a little bit more.
Fine. Yeah, let's look at that. I agree that's a. By the way, Sandra is suggesting the very simple heuristic: try running the plot. If it's empty, then evaluate. Try running the plot. That's a little scary because evaluate could blow up a lot of stuff. But I kind of agree that that's most likely what one should do. And at the very least, if it's going to produce an error message, just said you probably need evaluate. It's also the case, by the way, that, and this is something we could feed to the code assistance team, that some of these cases you can pretty much predict you're going to need evaluate.
Mm-hmm.
See what I'm saying? And we could actually do that in the code assist auto suggestion thing.
Right. I mean, the other thing that just occurred to me is that potentially the suggestions bar could also recognize when it got an empty plot out.
That is a good idea. Look, there are multiple places. This is a common error. People shouldn't be being bitten by it. We should be able to deal with it. But that's very swank that works. Do you think that would work with callout as well?
If it worked with labeled, it works with callout.
Okay, swank. Okay, are there any plans to enable plot layout in plot? that's not. It works for list plot, but not for plot.
Right.
Correct?
I mean, I assume they mean the multi-column sort of thing, and the answer is yes. We're just doing data things first.
Okay. Okay. I think we are. Oh, I'm sorry. I didn't look at complex stream plot, and I just want to have a quick look at that. Let's go back to these complex things. So this thing here, we should see the force lines of force, so to speak.
Ooh,
and it pinks.
What is? I was predicting a crash.
Vector style thick. Obviously, it needs to know that that's not an option. But okay, why is that? Why is that?
That's a bug that's since been fixed.
Okay.
But yes, it would be the stream plot equivalent of.
Well, and what color are the stream? It's just blue stream plot.
Just normal blue stream plot.
Okay. Okay. Fine. All right. Let's see. We have a question here from Javier. You're going to kill my session with variables like D. That is a bit disappointing, isn't it? That has to do with, oh boy, that has to do with the evaluation stuff again.
Mm-hmm.
Because this, I suspect,
will both look the same.
And they'll both look like the first one here. There.
Yep.
Yeah. That's not great. It's a good example, actually. You should probably capture that one, Brett.
Right. I mean, Roger and I were just have been discussing that we need sort of possible issues highlighting the evaluate, cases.
Yes, but also that's not good enough. I mean, we really need to solve this problem.
Yeah.
Code assist, suggestions bar, messages, and hopefully an actual execution time heuristic.
Mm-hmm.
All right. Do I need to keep this beautiful notebook?
I don't think so.
Okay. All right. I think we're on to a new topic. What's the next topic? Roger, what's next?
So we have there's a little bit left you want to do on calculus, and we have graphs and networks, and we can pick either one.
Should we try and nail calculus and then do what we can on graphs and networks after that?
Sounds good.
Okay. All right. Where am I going? Can you send me the relevant stuff for the calculus?
Yeah.
I actually have it saved in your Dropbox.
Okay, great.
It's in the top level of SW notes. It's called Calculus and Algebra, and then a date.
Okay. Oh, that's a new cloud feature. Okay. Right. Hold on. Calculus and algebra, thank you. By the way, generally, it's not great to put them in the top level there rather than a subdirectory, but if there wasn't a subdirectory, so be it.
Yeah, I couldn't find one.
Okay. All right, where are we looking at first?
You wanted to look a little bit more. I think we were sort of done with the asymptotic stuff. And you wanted to look a little bit more about Hoyne functions you didn't have time to look at.
Fine. Okay, so with the asymptotic stuff, what I got convinced by is we agreed we're going to make series work with inactive integrate and so on, and that otherwise this looked quite good. And we're going to make the notation, this notation we're also going to make work in series. Is that correct?
Right.
Yes, I spoke to Danny about it, and he's going to work on it.
Okay, fine. And it's very impressive that the prime stuff and so on, being able to do asymptotic estimates there is very impressive. Just so I understand, the scope of things, like the set of theorems that exist about asymptotic behavior of discrete functions. Do we have most of them implemented?
No. Well, it's a longer story. The first batch of things we do are things that we could find that people have recorded
Mhm.
Okay, and we've probably not found everything because it's sparsely spread out. So we'll make some attempts on that. Then, how people actually derive these asymptotic estimates, we actually have the tools to push that envelope too. That's going to be a slower pace when we have to derive them ourselves.
Yeah.
But for instance, stuff like Lindelof representations of some of these sequences, which are integral representations, and then we use the asymptotics of that integral, etc.
Okay. But so I mean, for things like, I mean, if we look at the number theory functions, for example, how many of those do we have asymptotic estimates for?
Well, that's the statistics I didn't get.
I have looked at them, and actually the notebook is now ready, but I would say that we have about maybe 10 to 12 functions, and I couldn't find any more for things like Möbius mu or whatever. So in some cases you might have some limits, but no asymptotics.
But I mean, there are definitely things like sums with Möbius mu's. There are asymptotic estimates of some of those, right? I mean, I know that there are. So, and I mean, if things like prime omega, that probably has asymptotic estimates.
I didn't find any, but I can check with Charles. So
we should probably ask some of our outside friendly experts about these.
Yeah, as I said, I'm going to get this. I wanted to get this report now because we had a strategy, which I think is not indecent, and I just want to make sure we execute that first strategy to find them.
Okay, fine.
As far as we can, and then then beyond that, things will accumulate more slowly, and in some cases, as I said, we can push ahead too because we actually have power.
Is this Oleg territory, or does Oleg only do continuous functions?
No, yeah, he only does continuous functions. These are not really functions to him.
Oh, well. Are you sure? Did you ask him? I mean,
yeah. No, he doesn't really.
Okay, fine. Okay, let's move on. This is very beautiful stuff. Very nice.
Thanks.
That's really cool. That's really cool. So if I do an asymptotic R solve on like the Fibonacci thing, I will get.
That's right.
Yeah, you get a leading term basically. I mean, yeah.
Oh, here. So let me just.
However many you want.
Yeah. So if I do this and I say A of n equals A of n minus 1 plus A of n minus 2, A of 1 equals A of 2 equals 1.
Oh, I'm not sure that's, yeah.
That's why I'm trying it. Magnificent.
Right.
Now, let me try doing the subleading terms, because that order, that's something of a certain order there. So let's try doing 4 terms here. While.
Now, well, at that point, no, what should we really return? Because do we want, I mean, you really have a closed form over here. Basically, you have 2 things. So if you make it a little more.
Fine. So I mean, let me do something more wild.
Right. So you could like modify exactly something. Well, no, I think that's not linear anymore. So, but there are these kind of modified Fibonacci numbers. I don't know what they're called, but Fibonacci numbers, something of that sort. So
well, wait a minute. If it's not linear, why can't we do anything with it? Can we not get asymptotic estimates in that case?
So for recurrence equations, it's severely limited for nonlinear. They're almost nothing. So we need to strengthen that. On the other hand, the linear case have become very strong in that it can have
what the heck is that? That looks completely magnificent. What is
right.
it?
So that's
that's what I'm going to say. It's still linear, though, right? So that linear theory was developed by
Birkhoff
and Trzynski. Yeah, following it's 1910, and the final paper is like 1935. Trzynski was in here, by the way, in town.
Yes.
Huh.
Yeah. And other Birkhoff students, actually.
That's incredibly cool that works. I mean, look at that limit. That's a good example, by the way. Can I send you that one?
Sure, please.
Yeah. So that linear theory, with meromorphic coefficients is completely sorted out.
Okay.
Yeah, you can put something like cosine of what when it should spell it out, like, with the same meromorphic behavior. I mean, you have to make sure that they actually have something of that. It probably should work now. Oh, sine of n pi over 3. Is that? Let me just think.
It's not very meromorphic at infinity. So pick something else, like,
sine of pi over 2n, something of that sort. Something which is actually meromorphic, then you're okay.
Well, that did okay. I mean, that's wiggling a lot at infinity.
Right, but I think you need to have meromorphic at infinity, basically. That's the condition you need.
I see. Okay, well, anyway, but this is very impressive. I'm really impressed. I mean, this is really useful, and okay, so we should be able to, one day we should be able to take a bunch of our algorithms. Now, the question is, do we have, for example, if we take the compiler, okay, which has decent analysis of certain kinds of code, are we able to digest that code into something where we can do these asymptotic estimates? That's more a question for Roger. I mean,
right. So this is sort of automated analysis of algorithms.
Yes.
Which is something I want us to do. We have almost all the core building blocks for it, but in terms of sort of meeting the ground, we need to. The right way is something proposed by Schutzenberger in the 60s, which is basically specifying a grammar for how these events are generated. That you can map to a programming language really well. So from that, we can get a giant generating function from which we can get the asymptotics, or we can get the functional recurrence equations from which we can also get the asymptotics.
I just wonder, in terms of generating recurrences, I mean, like from a Turing machine, for example, I wonder whether there's because I did some analysis at one point of some Turing machine, just to give you an example, and I don't know whether this is automatable. I'll show you one thing. Let's see if I can pull it up. Let's see. Let's see. This guy. I mean, this is an example of just absurdly. This is just some particular Turing machine. I have no idea whether this is automatable, but that's its running time computation.
I think most algorithms that you want to kind of analyze, even if you don't, I think most algorithms are not that complicated, actually.
Well, most that humans write are not that complicated, but a decreasing fraction are written by humans.
Right. But I think that's still the very cutting edge of what we can hope to do at this point, I think, in terms of getting
fair enough
fully automated.
Right. I mean, so the question would be, given this algorithm, like Euclid's algorithm or something for GCDs, given this input, what is the, figure out the recurrence equation for the running time?
Yeah. So today, you would teach that in a basic data structures and algorithms class. You would teach how you do accounting, basically, for that algorithm to set up a recurrence for it. And if you give us the recurrence, we can solve it. If you give us now the generating function, we can solve it.
I understand that. But so the question is, given the algorithm itself, you're saying if you tag it as every multiply costs this amount or whatever else.
Right. So then there is another step to get even closer to that, as I said, which is that you want to be able to tag kind of algorithms and automate that whole.
Okay. Let's go looking at Hoyne functions. I think Oleg has been promoting Hoyne functions for the last several years, hasn't he?
Yes,
sure.
Because that was the next kind of target after hypergeometric.
So I have no idea what they are.
Right. So they are kind of a generation of hypergeometric. They have got 4 regular singular points, 0, 1, infinity, and arbitrary.
As the years go by, we're going to have more and more regular singular points.
Right. And Roger knows.
Is that? Are you serious? Is that the number of arguments of this function?
Yes, because the differential equation itself is massive. I mean, it's not easy to work with. If you look at the differential equation, it must be somewhere over there, and then you'll see that it actually requires the arguments to get anywhere.
So are we sure we don't want to put those arguments in a list?
We could do that, and Roger.
Well, we're going to have to use lists. Special functions people hate lists because nothing works for them.
Our special functions people?
Our special functions people. And that's mostly because of derivative and a few other things that don't work properly.
But so do all these Hoyne functions have this many tentacles?
No, that's a general Hoyne function, which is like the hypergeometric 2f1 or PFQ. Then there are confluence which you got fewer parameters.
Well, it's not PFQ. It's a limited number of parameters here, right?
Right.
Sure.
Yeah, but
so PFQ said he does use lists.
Yes.
I mean 2f1. I'm talking 2f. I'm sorry, 2f1. It's more like 2f1. I would say 2f1 is a better analogy over there. In fact, 2f1 is a special case of Hoyne.
Okay. So if I want to go wild here, I could do something like this, and I could say, is this crazy? If I could say complex plot, so this is just checking.
It's going to be very, very, I don't know how well it works, but you can try it for sure. It might be computationally very slow, but yeah.
How are we doing the numerical approximation to these creatures?
Right.
So they're doing continuation. They're literally doing continuation of the differential equation.
And why are we not trying to use like machine learning to try and get estimates?
Of what?
Of the values. We just run it for lots of cases and we try and generate a neural net that basically approximates the function.
Yeah.
I mean, it's a high dimensional function, so obviously we're
I mean, first of all, we do this in order to guarantee it. Okay? I don't think machine learning could guarantee a thing, to be honest.
I don't know. Depends on what we know about how smooth the function is.
Yeah, I don't think that there's any work that shows that it can guarantee digits of precision.
The other thing is that if you stay inside the unit circle, maybe it might be quicker because there's not that much continuation to do over there. And it
so what is it doing here? It's doing. You're saying it's actually doing analytic continuation in the wild live.
Yeah.
Because I mean that it's if it can, it'll reduce to hypergeometrics, and I think there are 180 known special cases over there where it reduces hypergeometric, but those are few and far apart compared to the general Hoyne function. It's just a plot 3D works, but it takes some time.
Okay, so let's go unit circle here. Oh, that's not quite the unit circle. You want me to be actually within the unit
inside
circle?
And see, I mean, you want a radius which is inside.
All right. Okay.
But I'm not sure that even that it will be slow. Plot 3D barely. I mean, it takes some time, but it will work.
Well, but this thing returns complex values, doesn't it?
Yes.
Yeah, of course. Yeah, sure. I'm just saying that in terms of competition, the best I've tried is plot 3D.
Okay. Well, we'll let that thing run for a moment. Okay.
Sure.
So, other than the fact that these have a giant festival of arguments,
yeah.
Are there any branch cut issues that are? I mean, I'm sure we've done as well as we can with the branch cuts for these.
Right. So they got 4 singular points. One is a regular singular. One is 0, 1, infinite. The fourth one is arbitrary, and so that you can pick at will. And then your branch cut gets determined by that 4th point, basically, because everything else is kind of fixed based on hypergeometric 2f1.
And do we have to basically think about, oh, look at that.
Not bad.
Swank. That's really swank. Why is it all red?
I don't know, Roger. Stephen, I don't know.
Roger? Any idea? I mean,
well, that indicates
phase.
Phase is constant, which seems
to suggest that it's real. It's a real number.
It's implausible.
Try. I mean, it does seem very implausible. That suggests that if I pick a random value here, 0.7 plus I or something. Well, okay, that wasn't inside the unit circle. Let's say 0.2 I. No, I don't believe this. Something went wrong. I mean, we can. This will just give phase, right?
Yeah.
I mean, it's beautiful, but it just seems wrong.
I agree. That doesn't seem right at all.
Okay. Okay.
I don't think it's possible for it to. Yeah. It's just...
Well, I mean, maybe there's that suggests some problem with the heuristic. What?
Oh, it's the same color. No, I'm kidding. But what the heck? This looks like. No, it is the same color. It is the same.
Oh God, it's actually pink.
Yes, it's actually pink.
It's positively pink, like the panther. I suppose it's not a pink error; it's a pink function.
Okay, but there's something
Funny.
fishy.
Yeah, it's very fishy. I mean, if I change that to like 2 or something, let's see what it does. That is a classic, if I might say so. I'm going to save this file because that's just such a bizarre and classic thing. I've never seen a thing that looks like a pink box actually generated by a function.
Yeah.
Did you move the where this was in the design folder? I think that was Devin who was doing that.
No, I didn't touch anything else.
Okay. Oh well. Where did this? Oh. Yeah, I see. Hold on. Okay, this is wrong. Something is very wrong here. Okay, I mean, it's probably a math problem. All right, anything else we need to look at here? Looks like we're done with the calculus stuff, yes?
I think so.
Nice, okay. And what can we, what is the Hoyne function hooked up to? I mean, what integrals and things can be done?
Desolve. So its primary purpose in life is to, it's defined by differential equation, and it's able to handle these additional singularities compared to 2f1. And so Tigran, who just finished his double PhD.
Exactly.
His dad worked on Hoyne functions too. Could you believe that? Anyways, there's a lot of quantum.
Wait a second. You're saying a 2-generation Hoyne function?
Yes, 2-generation Hoyne function specialists. And in his PhD, he gave a lot of quantum physics applications.
Yeah, quantum computing kind of. I mean, like so quantum physics and also black holes.
So there are in the application.
Oh yeah, I've heard Hoyne functions are used in modern ADS-CFT stuff.
Yeah.
So they're quickly picking up, and I think it's good that we have them right now, so that it seems that people do use them.
Okay, well, don't forget to promote them. Don't forget to tell the black hole people that we have them.
Yeah, we'll probably write a blog post at some point about. Tigran will.
Okay, fine.
Yeah.
Great. Okay,
Thanks,
let's
Steve.
move on to the next thing. Good work. All right, what's next? Graphs and networks, right?
Right.
Devin, do you have that file somewhere placed for me?
No, I was only included for the calculus discussion.
Not a problem.
Okay, where is that file? Roger, did you?
I'm going to send a new one. It was in the calendar before, but okay. I'll send you a new one.
Okay. And so remind me what we were looking at annotations yesterday.
I sent a link in chat.
Okay.
And we have geometry too. So, we have only 15 minutes left. So it's like, no.
What were we doing in geometry again?
Well, there was the topology and metric searches. So.
Oh yeah. I really want to see that. You didn't send this in chat. Could you? Oh, maybe you did. Hold on.
Well, not Rocket Chat, but the Zoom chat.
Yeah. Okay. Okay, I didn't get it. Could you resend, please?
Oh, wait a minute. It says send to. Okay, now I see why. So that's the geometry one. So let me get the graph and network one. It was somehow it pointed my chat to Charles only. There you go, both of them.
Okay, so wait a minute. Geometry, we had not finished the discussion about how to do all these various shading things. There was a great functionality, but we're not really finished with figuring out precise details of how everything will work. We're close.
Right.
we didn't look at this at all.
We didn't, yeah, exactly. And we looked very briefly on geometry and geography. And I don't think that there is much to say.
I actually think the geometry and geography I was pretty happy with. I mean, I understood what that was. That's being able to do things here. I mean, I assume, oh, I see, geo area. So if I just do a straight geo area of the United States, okay, hold on. Let me just try this. I'm trying to understand this. So if I say, okay, I'm going to look at a couple of different things here. If I say geo area of US, then it's just going to go to the area property, isn't it? It's not recomputing that, is it?
I think it's just the area property. I'm pretty sure it is.
It's not.
It's not.
Okay, so we got an issue here. And I think the issue is going to be even more extreme if we do this. So I reckon we probably don't know that area.
So that area is sort of entity stored area.
Exactly. But if I say geo area of Sydney, now if we have the boundary of Sydney, which we may or may not, okay, fine, not available. But that's an issue. I don't know what I mean, again, the geo area does, what does it do with lakes? What does geo area
I mean,
do?
what's comparable for us is geo area, in terms of geometry, because that's computing something. And then there's a question of why are they differing, the entity stored value and the computed value?
I understand that, but I want to know about lakes. What happened to the Great Lakes? Do you see what I'm saying? Does geo area include the Great Lakes or not include the Great Lakes?
I see.
Because I can imagine that one of these is the political area, so to speak, the controlled area, and the other is the polygonal area.
Well, geometry just looks at geometry, whatever polygon.
Exactly. Well, so it's not going to know, like, the territorial waters of whatever. It's not going to know.
Right. Unless, I mean, the polygons can include holes in them.
Absolutely. But I think that, okay, the polygons, look, what you're seeing here is that the geo area is smaller, suggesting to me that the Great Lakes have been chopped out of the United States polygon, but they're not chopped out of the United States political area, so to speak. Do you get what I'm saying?
Yeah, I get it. It could also be that, I wonder what that polygon, if that's sort of the lower 48 only.
I don't know, but I think Alaska is bigger than that, but I'm not sure. But in any case, so look, there's an issue here. So I don't know if Jose is here. Probably not, because we didn't think we were doing this particular thing, right?
Right.
Okay, you were right. No Alaska. Whereas I bet this includes Alaska.
Right.
Okay, and we've got a geovariant here. This thing here allows geovariant. It's going to get complicated, right? So I think this just becomes a possible issue to say the area isn't necessarily the same as the declared, political area, so to speak. Make sense?
Right.
I don't think this is a problem.
No, I think that's the same ambiguity that's been dealt with for years there.
Right. And so in the case of region centroid, what we'd be doing there, in that I see. So in that case, we'd be saying, okay, so let me just understand. If we do region centroid of, well, the United States, for example, what? Why not?
It doesn't work on the entity. It's built on the geoposition polygon. So you need to get the geoposition polygon out.
But that one did work on the. Oh, it's a region centroid. So it's not a geo-region centroid.
Yes.
So you're saying if I say polygon of that. No, why didn't that work?
No, so you have to actually get the property which gives you the geogrid position.
That's not sensible. Look, come on. I mean, why can't I take this region? See what I'm saying? I mean,
The question is that because if you view it as a polygon on a
right, but this
on an ellipsoid, the centroid will be inside of the Earth.
Exactly.
For sure.
But this worked, right? So geographics of polygon of US worked. So I don't see a reason why region centroid shouldn't. I mean, if I say, okay, so let's say I say geo area of polygon of United States. Where did I have that? Sorry. Yeah, that worked. Geo area of that worked.
Sure.
But area, does area work on that?
No, it won't work.
No, I see. So what do I have to do here?
So in this case, you actually need to like press, if you want to actually compute the area, you have to precise the projection. So you need to actually extract from the United States the coordinate and generate the geoposition out of it. So
So if I were to say, okay, so if I were to say geoposition here, that's really confusing, considering that, okay, so wait a minute. If I say this, are you saying that that will finally work?
No, because it will be polygon of 1 point. Right.
No, it won't, because this isn't a polygon of 1 point.
What's geoposition?
No. I mean, what you type there, polygon of geoposition, the geoposition will return 1 point.
It won't. Look at this case here.
No, in that case, you extract the coordinate and then we apply the Mercator projections compared to your comment, which is.
Well, I'm confused by this. I think we need to look at this a little bit more. Let's try to understand for 1 second. What you're saying, if I were to say geoposition, geogrid position here,
Well,
then
so essentially you have to describe, give explicit geogrid position, will tell us essentially you are giving the position on the map of that polygon, so we know actually the.
But still, just 1 point though.
Yeah, that doesn't make sense.
But how do you get? I don't know how you get it out from entities. How do you get?
If you ask, I think coordinate from entity, I think there is a property.
No, that's not going to give it because coordinates would give. Okay, this is very confusing. I think
the question is how you get it from entities. We know how to get it.
No, coordinates there. He's got the thing.
Oh, is that entities? Oh.
Right, it's country data.
But that's not entity.
I don't know. So we need, okay, this is messed up. Okay, we need some thing here. And then the question of what this should do.
I mean, the idea is simple. I mean, this issue is on the entity side, how to extract geoposition or geocoordinate.
I understand. So we don't have the right people here to answer this. Right? Okay. In the time that remains, why don't we take a look at these things here?
Okay.
Mesh connectivity graph, adjacent mesh cells. Okay, which should I look at here?
Any of them, but go to the ref page because it's where the information is. Now, let me explain the simple case for a mesh connectivity graph.
Okay, so let me bring up a Menga sponge or something.
Sure.
Okay.
Okay. So the simple case is where you kind of almost see where the graph is, which relates to, vertex-vertex connectivity.
Cool.
Okay. And that's what it does by default. That's just the default setting. Okay. But there are many other kinds of connectivity because the way a cell complex is built, it has points, edges, faces, and general K faces. Okay. And So all of these can be related. So the question is like, what are the edges that are neighboring my points?
I see. So this is looking at two complexes or whatever.
And this one looks at where are the rectangles near each other, and the edge represent near. Do you know what I'm saying? Next to each other.
By rectangle, you mean the little regions inside.
Yeah,
here.
The little regions inside are no nodes in this graph, and the edge says that two of those rectangles are next.
By the way, that should presumably generate a message.
Yeah, it's too big of a dimension.
Yeah, obviously, I know, but I'm just suggesting it generates a message.
Absolutely.
Okay, so those are the edges.
Right.
Okay, so can I take a sample like dinosaur or something?
Yeah.
How do I get a sample dinosaur?
Yeah, well, web region search is probably the easiest. Or you can take the cow from example data or something like that.
Let's take the example cow. What is it called? Geometry 3D?
Yeah.
Why didn't that work?
I should just probably give you a bunch of names.
Okay, let's take the cow. Okay, there it is. Moo.
You should probably request a mesh property.
Oh yeah. Let's get it as a mesh because this operates on meshes. Otherwise, you need to convert it to a mesh and stuff like that.
What is this? Is this a graphics 3D here?
Yeah. So
okay. So what do I
get it out from example data just as a mesh region directly. Now you have the right thing. Okay.
Okay. So now I can say mesh connectivity graph.
Yep.
Of that guy, and then the default is points. So it's going to be a cow-like graph.
Right.
Okay, but that graph is not a 3D object. That's just a graph, right?
That's just a graph, yeah.
Excuse me, why is that rotating in 3D?
Because we have graph 3D, right? You can pick a 3D.
So it's choosing, I see. So it knows it's a 3D object, so it's embedding the graph in 3D.
Apparently.
Right, because we use the coordinate of the point or the vertices of the image.
That works fairly well for 3D objects.
Yeah, it's obviously a good idea for 3D objects. Okay, so if we go here and we do the cow, and we do like regions of the cow.
Yeah.
So that will be a similar but almost dual to this picture. Is that correct?
Yep.
What the hell is that?
That is that.
What the hell is that? That's a dual cow? That's really wild.
It tells us how those patches are neighboring each other on that cow, topologically.
Well, that's my favorite picture from the day.
Like
somehow it reminds me of modern string theory, holographic principles and things of I don't know what. Okay, so wait a minute, explain this to me. So that the hooves of the cow. Well,
I mean, we can do a super simple example where we can reason our way through it.
Okay, but this is a great function. Okay, so what else do I need to know about this function?
That's it. It gives you, so if you're in 3D,
By the way, I hope that this is referred to on the guide pages from graphs because there's a useful way to generate graphs.
Oh, obviously, yes. It's not done right now, but we have all that knitting to do. One thing here is that if you're in dimension D and you have a cell complex, there are immediately D plus 1 squared such possible graphs or relations.
Okay.
And usually a geometric data structure is optimized for one or two of those relations. They make them very fast.
Okay.
So, but anyways, here you can get them all, and they are actually fast to work with in this graph. But the other one that's there, adjacent mesh cells, is the nearest goes based on this. Ignore that illustration.
Okay, so wait a minute. So I should look for adjacent mesh cells, is that correct?
Adjacent mesh cells is very close to what we just looked at. What that does it allows you to walk the mesh. I mean, the graph allows you to walk the mesh in however way you want to, but the adjacent mesh cells. So you have the mesh region, and you tell, I'm at this cell, and I can tell you whether it's a sort of an area cell or a line cell or a point cell and so on.
Okay,
right?
so if I go to the Menja creature,
Yeah.
So I would say adjacent
Mesh cells
of that, comma, and then let's say cell 4 or something. Is there a cell 4?
You usually the short form to give it is to sort of say dimension, comma, index. So list dimension, comma, index. So let's say like a point 0, comma, I don't know, 5 or something. Okay. And then what is it you want? So we need to say what you want next to it, dimension, like the nearest 1. So nearest edge.
Okay. So for example, why can I not do this in a graph? Could I do this in a graph? If I pick, if that is the specifier for a node in a graph.
If you built the correct relation that has the relation between points and edges, if you have that graph, then you can absolutely do all that. And it's in fact optimized for doing lots of that.
Okay, but let me just try to understand this. So the specifier of a cell here, have we used that kind of cell specifier before or not?
Yes.
Where?
All the mesh regions, boundary mesh regions. And
so they have dimension followed by index, is that correct?
Correct.
Okay.
You can also do another thing, which is you can have sort of point of index, as it's used in graphics complex. That's a
point of index. So I mean, if I go here, for example, let's say I say something like this. If I say adjacent cells hash, comma, whatever it is, hash. Oops. No, it's in this object. I'm going to go those cells, comma 1. And then I say that starting with 0, 5, and then I go 3 steps or something. I don't really know what that means.
That was what was comma 3? Oh, wait a minute. What did you do?
Well, I'm walking out in the graph. So each one of those now becomes a source, right? So if I were to do that for
one. Okay, so edges out. Yes, right. Okay.
If I do that for a Sierpinski mesh,
those indexes may or may not be sort of spatially. Well, it's interesting.
Cool. And if I do that for a denser Sierpinski mesh, okay, well, it's hard to tell exactly what's going on here, but it looks plausible at least. Okay.
So that's the topology of a mesh that you can now follow within whatever dimension. Do you know what I'm saying?
Well, you're walking, you're doing spreading across the mesh by looking for adjacent cells.
Exactly.
But you don't have any particular way to know what direction on the mesh you're going, because that isn't necessarily defined.
No. You don't. You have no clue. Then you need to look at the embeddings. Right. So this is the part of a mesh that's kind of irrelevant to embedding. You can even have an abstract mesh.
Okay. Nearest mesh cells. Is that going to just tell me if I do the same thing for nearest mesh cells here?
Now, nearest is just using the distance. What is nearest? So that's using the metric.
As opposed to what?
This one used topology. The other one used topology.
Oh, I see. So in other words, if this was across a void, it will still get there. Whereas this is using connected. This is saying it's connected, and that one is saying across the void, it's the closest.
Yes.
Okay. Okay. Practical point. Do we have any more time, or do we have to wrap right now? I could go on for a little bit.
I gotta go, unfortunately.
Okay. what are can we just look at what we're missing? I mean, so we haven't done. We still need to come back to this. Who's making a note of what we need to come back to?
I can make note of it.
Okay, all right, and then the thing we haven't done is
web region search is probably you wanted. Did you guys finish that off when you continued?
We haven't finished the shader.
Shader.
No, we have not finished shaders, and we also haven't finished. We really haven't finished this. We really haven't finished this. Well, mesh connectivity graph we looked at. We didn't look at winged edge graph.
They're not available now, but they're similar in nature. I can.
Okay. That was just documentation changes in number theory, although I had some objections to some of those.
Right.
But the annotation rules we looked at, did we finish that? We felt that we'd finished the tagging stuff. We convinced ourselves that edge tagged graph made sense. Right? And yes, I think we came to conclusion on that.
Yes.
Okay. Well, we're pretty close here. I think we've probably got a little bit more stuff to look at, but we're pretty close. And I don't know what other. We didn't look at find maximum cut or any of that stuff.
That's right.
But what happened to vertex labeling?
We went through and it was an intern project, and we've optimized the label placement for all of the layouts.
Okay. By the way, Charles, I would really like, okay, little gift, okay? Could you give us an option for spring embedding to give initial points for the spring embedding? We're trying to generate something where there's a sequence of graphs and they are related to each other, but they are going to need to move the points around slightly. You understand what I'm saying? I mean, you must have initial data for the spring electrical embedding, correct?
Correct. I got the request from Mark's team about that. While the require is not that obvious for several reasons, but we'll see.
It would be really nice. Otherwise, we're going to end up having to write our own. Okay, so for example, if I say here, what's a good graph? If I just say random graph, whoops, why is that not working?
You need to give a list of vertices and edge.
Oh, yeah, right. So that's not optimal. Why didn't the 5 go on the outside?
This is spring electrical.
No, I understand that. I understand, but I'm asking the question, since you just told me you've optimized these things, why did it go?
It's optimized all the fixed layouts. So we have a huge collection. A complete graph has a fixed layout. It's not spring electrical.
I see what you're saying. So you say you've done the artistry of doing it for the fixed layouts, but you have not yet done it for the arbitrary layouts.
There's some tweaking, but it needs, there's another round that needs, and it's kind of heavy optimization.
And how does that relate to the labeling in geographics and things, which is a similar?
There's another labeling problem.
Okay. What happens if I go to 3D here? Why isn't this rotating?
Should be.
It isn't. It's just refusing to. Oh, now it's doing it. Well, that's quite swank. Yeah. Was that working before?
Yeah.
It's really nice. All right, let's, I guess, so Dong's on our live stream is saying he's been working with a heavily labeled graph taking connectivity data from a flow sheet simulator and trying to make views of that network, and it's frustrating. Don't know. I mean,
we would love to get some of that. I think we have a lot of interesting things coming.
Send the example in.
Yeah,
please.
I gotta run. I'm really in trouble now.
Okay. All right. See you. Okay. All right. We should probably wrap up here, unless there's unless there's something else we think we can cover without Roger. Nope. Okay. Good stuff. All right. See you guys soon. Thank you all. Thank you, folks on the live stream. Probably next live stream, since I'm traveling next 2 days, will be on Monday. Talk to you all soon. Bye.